Good morning friends, myself Prof.AJAYKUMAR, and today we are going to study about the most important interesting phenomenon in the chemistry, that is nothing but the Anti-Markovnikov rule. So let's begin. Anti-Markovnikov rule. This rule popularly also called as peroxide effect. Peroxide effect. It is also called as Kharasch effect. Kharasch effect. It is also called as Kharasch effect. Friends, last lecture we have discussed about the Markovnikov rule, and now we are going to study about the Anti-Markovnikov rule. What is the Anti-Markovnikov rule? What is the anti? That is the question. Anti means opposite, against. Who's against? Against of Markovnikov. How? So now आपण पाहू. ठीक आहे. So, Anti-Markovnikov rule state that when an unsymmetrical alkene or when an dissimilar olefin react with unsymmetrical reagent, here the reagent is specific, that is the HBr, hydrogen bromide. Then what will happen? The negative part of the adding reagent or addendum, that is the bromine, get attached to that carbon of carbon-carbon double bond which possess the higher number of hydrogen atom, leading to the formation of primary alkyl bromide. This is called as the Anti-Markovnikov rule. Friends, as a matter of fact, this reaction is directly reverse of Anti-Markovnikov rule, and it is derived, or we can say that it is departure from the Anti-Markovnikov rule, and hence it is called as the abnormal reaction. So after this, why it is called as the peroxide effect? Why it is called as the peroxide effect? Because the reaction with respect to this reagent, that is the hydrogen bromide, the reaction does not occur without the peroxide. If we didn't use the peroxide, it gives the formation of secondary and tertiary alkyl halide as like the Markovnikov rule. It is the complete Markovnikov rule. Hence, we have to use the peroxide for the dissociation of water. So now let's take example. Friends, we can see this reaction is almost same as like the Markovnikov rule. Same alkene, same unsymmetrical olefin, same almost reagent is used, but only difference is that here we have used the catalyst. So what is the statement for reaction? When an unsymmetrical alkene or dissimilar olefin reacts with the hydrogen bromide, that is halogen acid, in presence of the catalyst, maybe inorganic catalyst, hydrogen peroxide, benzoyl peroxide, oxygen, UV light, you can say any, leading to the formation of primary alkyl bromide. You can say that L-propyl bromide. So what happened during this reaction? Simply we know that here you can say that propylene, that is propanine. Here you can see the HBr. What will happen? The homolytic fusion takes place. Homo means same, lytic means cleavage, dissociation. How this takes place? What is the definition of homolytic fusion? The symmetrical breaking of covalent bond in such a way that the one electron from the bonding pair retained by each atom is called as the homolytic fission, and homolytic fission takes place in presence of peroxide, or in presence of light, or in presence of oxygen. So what will happen when the homolytic fission takes place between the HBr? The one electron retained by hydrogen and one electron retained by bromine. And so we can see that here is a propylene, and propylene is the unsaturated alkene. There are the doubly bonded two carbon atoms. So what will be happen? We can see that one is the sigma bond and another is the pi bond. And we know that the pi bond is nothing but is formed by the lateral overlapping. Yes or no? This is the most loosely bonded electron. Right? And what will happen? This most loosely bond will break, and this electron, one electron retained by carbon, this carbon and this carbon. Then, according to this rule, according to the Anti-Markovnikov rule, this bromine atom attack on this first carbon atom, which possesses the higher number of carbon atom, and remaining hydrogen atom on this central or middle carbon atom. And so in such a way that it gives the formation of N-propyl bromide. Or we can say that 1 bromo propane. So this is the simple reaction when propylene reacts with HBr in presence of the peroxide, maybe organic peroxide, alkyl peroxide, inorganic peroxide, maybe benzoyl peroxide, maybe hydrogen peroxide, maybe R2O2, maybe O2. So it gives the formation of alkyl, that is N-propyl bromide. Now we have to take the another example. Write down the next example. When butylene in bracket but1 react with HBr, that is hydrogen bromide, in presence of benzoyl peroxide or hydrogen peroxide or oxygen, it gives the formation of N-butyl bromide. N-butyl bromide, that is 1 bromo butane. So CH3, CH2, Cl double bond CH plus HBr in presence of C6 H5CO2 O2 or H2O2 or O2. It gives the formation of CH3 CH2 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 Br. This is butylene or but1. This is the hydrogen bromide, and this is the N-butyl bromide, that is 1 bromo butane. As like the above example, this reaction can be takes place. Simply we can say that this is a unsymmetrical olefin, that is the but1 or butylene. What will be happen? The HBr first dissociate by the homolytic fission, and then the free radical is formed, and then free radical attack on the doubly bonded carbon atom, which has a higher number of hydrogen atom, and leading to the formation of primary alkyl bromide. And friends, in such a way that first thing, always keep in mind that the Anti-Markovnikov rule is a free radical addition reaction. What is the free radical? That is the question. What is the free radical? Simple. A highly reactive short-lived species containing an atom or group of atoms having an odd or unpaired electron, it is called as the free radical. Free radical are in the neutral, they are electron rich, they are They are highly reactive. And this is simply addition of free radical. This is a free radical addition reaction. So next question is that this reaction was only given by HBr and not HI or SCl. Why? What is the reason behind it? Anybody can answer? Why only the HBr is given by this reaction? This reaction is only given by HBr and not HI and SCl. This reaction was only given by HBr and not HI or SCl. What is the reason? Simple. HBr, hydrogen bromide, HI and SCl. We know that the bond energy, or we can say that the bond dissociation energy of HI is very low. How many? The bond energy of HI? The bond energy of HI is 71 kilocalorie per mole. Hence, the iodines are formed, they get easily combined with each other rather than attack on carbon-carbon double bond, or instead of attack on doubly bonded carbon atom. And hence, it does not show the reaction with alkene. Next, SCl. Why the reaction does not show by SCl? What is the reason? Because the bond energy or bond dissociation energy of SCl is above 100. Is 103 kilocalorie per mole. This is a very high, and it does not easily broken by peroxide. The peroxide, it cannot break easily and cannot form the free radical, and hence the reaction with KCl is not possible. Now HBr. The bond energy or the bond dissociation energy of HBr is 87 kilocalorie per mole, and it is sufficient. It is easily broken by peroxide and can form the free radical, and bromine can easily attack on this hydrocarbon chain and it gives the primary alkyl bromide. And in this way, this reaction is only given by HBr and not HI and SCl. So what is the bond energy? The energy is required to dissociate the bond, to break the bond. This is the bond dissociation energy. Okay? Are you understand? Now, we have to see the mechanism of the Anti-Markovnikov rule or peroxide effect. Mechanism. The detailed step-by-step description of the chemical equation is called as the mechanism. And the peroxide effect, the mechanism of peroxide effect involves 3 steps. So let's start. First, what is the function of peroxide? What does peroxide work during this reaction? Simple. CO, O, CO. This is a benzoyl peroxide. Benzoyl peroxide. So what will happen here? The homolytic cleavage will be takes place. 1 electron retained by each atom. Here the 2 same atom. We can say that here is oxygen, here is oxygen, there is a formation between them, there is a bond, simple single bond, that is a sigma bond, and these both atoms are same, means it has the same electronegativity, and hence homolytic cleavage takes place. 1 electron retained by this oxygen, 1 electron retained by this oxygen, it gives the formation of CO dot. These radical fragments. Then after that, what will be happen? These fragment, these two molar fragments, we know that the peroxide effect or anti-Markovnikov rule is a exothermic reaction. Which kinds of reaction? Exothermic reaction. Means what? Means the heat is evolved from system to surrounding. This is called as the exothermic reaction. That is, delta H is negative. The enthalpy is negative. है ना? आता याच्यामध्ये काय होतं, रिएक्शन मध्ये गॅस इव्हॉल्व होत आहे फ्रॉम सिस्टम टू सराउंडिंग, लिबरेटेड होत आहे. म्हणजेच तो गॅस कुठला असेल बाय, हियर देयर इज द प्रेझन्स ऑफ कार्बन डायऑक्साइड CO2, है ना. It will not be vapor, water molecule, it is a gas. Gas will be the CO2, carbon dioxide. So what will happen? This CO2 will be break here from here, or the position of benzene ring, and they will get released in the form of gas. है ना. Then what will happen? It form the benzene radical fragment. Benzene fragment. This first step. In next step, what will be happen? This is a unsatisfied aromatic radical. आणि आता याला सॅटिस्फाईड व्हायचं, म्हणजे याला जर आता सॅच्युरेटेड फॉर्म करायचं असेल, सॅटिस्फाईड व्हायचं असेल तर त्याला बेंझीन फॉर्म करावं लागेल. आणि बेंझीन फॉर्म करण्यासाठी दे रिक्वायर द वन हायड्रोजन ॲटम. देन व्हॉट विल हॅपन? इट रिएक्ट विथ द HBr. मग HBr सोबत रिएक्ट होईल. मग काय होईल? दिस हायड्रोजन here breaking takes place. This hydrogen attack on this side. You can see the all electron is present and they attack on this side of the carbon atom and it gives the satisfied structure of benzene. Now, and then you can see that the Br radical is liberated. So, in next step, attack of Br radical. Next, the hydrocarbon chain CH3, CH11, CH2. This Br radical attack on this chain. Here on this carbon atom CH3 CH CH2 Br. आता इथं पाहतो आपण की मोस्ट लूजली बॉन्ड आहे, पाय बॉन्ड आहे. व्हॉट इज द बॉन्ड? इलेक्ट्रोस्टॅटिक फोर्स ऑफ अट्रॅक्शन विच इज रिस्पॉन्सिबल फॉर द कॉम्बिनेशन ऑफ टू और मोर एटम विच इज होल्ड बाय दैट फोर्स. इट इज द बॉन्ड. आणि इथं काय होईल? या ठिकाणी ब्रेकिंग होईल. एक इलेक्ट्रॉन इथं Br अटॅक झाला, तो सॅटिस्फाईड झाला. एक इलेक्ट्रॉन या ठिकाणी शिल्लक राहिला. यू कॅन सी नाउ सॉरी here on the central carbon. Now you have to give the stable product, that is the N-propyl bromide. You can see that here the radical product, radical fragment, and now it is necessary that we require the hydrogen atom. Then again we have to treat it with HBr, CH3, CH, CH2, Br. पुन्हा एकदा HBr, पुन्हा एकदा होमोलेटिक फ्युजन, पुन्हा एकदा अटॅक. कशाचा? आता हायड्रोजनचा. कशासाठी? त्या कार्बनसाठी, कार्बन रॅडिकलसाठी. कशातल्या? हायड्रोकार्बन चेन मधल्या. मग काय होईल? इथं पुन्हा अटॅक करेल, म्हणजे आपल्याला स्टेबल प्रोडक्ट मिळेल. CH3 CH2 CH2 that is the N-propyl bromide. So friends, in this way we obtain or we prepare the desired product, that is the N-propyl bromide. In this way, as like the same, we can prepare the N-butyl bromide, and in this way we have discussed about the mechanism of the peroxide effect. In that we study the 3 steps, namely first is the formation of radical, then attack on radical, and then formation of product. And friends, these steps we cannot easily terminate or inhibit because of the continuously propagation step and continuously formation of the radical, and it is very difficult to stop this reaction. So we will stop here. Next lecture we will discuss in the next period. Thank you so much.